we're going to take a look at complex numbers. And let me just start by saying it's going to be okay. Part of what makes complex numbers and imaginary numbers scary is really just the name. So there was a time that society thought that we had all the numbers we needed, and we called them the real numbers. How arrogant, really, because with just the real numbers, not every quadratic equation has two solutions. So for example, x squared plus 9 equals 0 doesn't have any real solutions at all. So imaginary numbers is going to solve this issue. Just think of these non-real numbers as just being opportunity numbers, possibility numbers. It's just going to mean that every quadratic equation will have two solutions. All we really need to base this on, we're going to just do the bare bones here and not overdo it, is we just need a definition. So I is going to be defined. Here's the dictionary definition. I is defined as the square root of -1. So I is an imaginary number. Now, if you take that equation that's in the definition and just square both sides, then you get I squared equals, so that's squaring the left side, and then the squaring on the right side is going to undo the square root sign, so you're left with -1. So I squared equals -1. Okay? So here's the definition. I equals root -1. Square both sides, you end up with I squared equals -1. And that's a fact that comes out of the definition. Those are the two big things we need. If you stick with I is root -1 and I squared is equal to -1, things will be okay. So to simplify root -6, we'll just show a lot of steps here. In the future, you could just skip to the end of this. But root -6 is root -1 times 6. That's just a way to replace -6 inside the radical. Then we split this up using one of the radical rules. So we have root -1 times root 6. And the root -1, by the definition, turns into an I. So we end up with I root 6. So in other words, a negative sign inside the radical turns into an I outside the radical. Okay, let's talk just a little bit about the names of some of these numbers. Sometimes people are a little lackadaisical with some of the naming, and that's fine if you are, but let's just clarify technically what some of the names are. So here are some examples of real numbers: 0, 1, 3, pi. Here are examples of imaginary numbers. Basically, you always take a real number and multiply by I. So 0i, which simplifies to 0, and 1i, which simplifies to I. So that I here is sort of the primary imaginary number we think of, but also 3 times I and pi times I. Now, a complex number, technically, is the sum of a real number and an imaginary number. So pick something from this first list, add it to something from the second list. Of course, the first list, I've only gave 4 examples, so there's plenty of other examples of real numbers. So here are some examples of complex numbers: 2 plus 3i. Or here's another one: 4 plus 7i. Or 5 plus -2 times I, which we typically just write 5 minus 2i. Or pi plus -1 times I, which you could simplify as just pi minus I. Or 8 plus 0i, but if you just have 0i, which simplifies to 0, 8 plus 0 is just 8. So it sounds a little strange, but this number 8 itself is a real number, but it's also technically a complex number because in a more standard form, as a complex number, it's 8 plus 0i.